Now we will discuss about the collision theory of bimolecular reaction. So collision, from the name itself we can very well understand that is collision will means they will bombard with each other, they will collide with each other. So that is what happening in kinetic theory of gases. The molecules will come close to each other, they will dash against each other, they will react, and finally it gives you product. So based on this kinetic theory of gases, we are going to see the collision theory of bimolecular reactions. So first point itself is mentioned as it is based on kinetic theory of gases. So according to this theory, chemical reaction occurs due to the collision between the reacting molecules. So let us consider the example A2 and B2. When they react, you are getting two molecules of AB. So the rate is proportional to the number of collisions per liter per second. And the number of collision is proportional to the concentration of the reactant. So collision rate is what? Proportional to the concentration of the two reactants, that is A2 and B2. And the collision rate, proportionality symbol is removed and introduced one constant is Z. Z into concentration of A2 into B2. So here this constant is called as a collision rate constant. Now we are going to see the diagrammatic representation of the progress of the reaction. So along the y-axis we got the potential energy, and along the x-axis we got the how the reaction proceeds. So here you got the reactants. So this reactant must possess this much amount of energy. This minimum amount of energy is required by this reactant to cross this barrier to get converted into product. So the minimum energy that is required by the molecules to undergo reaction to form the product, that is called as activation energy. All molecules must possess activation energy. If the molecule doesn't possess this activation energy, then it will not undergo any type of reaction. So that is what here. So how many types of collision takes place between the reactants? If you check, 10 power 18 collision. 10 power 18 means what? 1 followed by 18 zeros. Out of those collisions, only 4 collisions are found to be effective. That is, the reactants will get converted into product. Only 4 collisions. So collision plays a very vital role. And this collision depends upon one of the factors, that is the orientation factor. Orientation means what? How the molecules they orient. Either it may come closer together in the vertical pattern, or it might come towards each other in the horizontal pattern. So if the reactant molecules collide, they will react unless the orientation of the reactant molecule is suitable for the formation of the transition state. If you see this diagram, self-explanatory. Proper alignment, that is the two reactants A2 and B2, how they are approaching each other. They are approaching in the vertical pattern. So this is called as a proper alignment. What is improper alignment? Here the reactant A2 and B2, they are approaching each other in the horizontal pattern. Here it approaches in the vertical pattern. Here it approaches in the horizontal pattern. If it approaches in the horizontal pattern, it is called as an improper alignment. If it is in the improper alignment, then the collision is found to be ineffective. Whereas here, when they approach each other in the vertical manner, then that collision is found to be effective collision, leads of product formation as AB. Whereas here, ineffective collision, you will not get product. Instead, you will get back the reactants. So this is out of 10 power 18 collision, only 4 collisions are found to be very effective. Based on orientation factor, the molecules will not react unless the orientation of the reactant molecule is suitable for the formation of the transition state. Now we will see the fraction of effective collision. Fraction of effective collision is represented by the letter small f. Having proper orientation is given by another factor that is called as steric factor, that is P. So we know what is steric factor and what is fraction of effective collision and what is collision rate, as we have discussed in the very first point. So for this we will find the rate. So rate is equal to P, the steric factor, F, the fraction of effective collision, and in turn is multiplied by collision rate. So you write the rate as P into fraction of effective collision is given as e power minus Ea by RT. E, that small letter e represents the exponent of minus Ea by RT. That Ea is called as activation energy, R is a gas constant, and T is the temperature, and in turn is multiplied by the collision rate. We have first expression we have seen, Z into concentration of A2 into concentration of B2. So according to rate law, we know the rate is equal to K into concentration of A2 and concentration of B2. K is called as the rate constant. So we got two rates. So we have to compare both the rate 1 and rate 2. When we compare both the rate 1 and rate 2, we can write the first rate and the second rate, and then we can do the simplification. We can strike out A2, B2 on both the sides. What is left out? K. K is equal to P into Z into e power minus Ea by RT. So based on collision theory of bimolecular reaction, the rate constant is found to be of this type.